In reaction set 7, we're going to look at double replacement reactions again, but this time we'll be putting states on each compound just like we did in the reaction set 6 in the lab. So we know in double replacement reactions we put the positive ion from one compound with the negative of the other and then switch the two remaining ions, and we work the charges again on the product side. And so in this reaction, potassium plus 1 forms a compound in the product side with nitrate minus 1, and you get KNO3. Silver plus 1 and bromine minus 1 form a compound, and we have silver bromide. The difference now is that we're going to put in the states. Potassium nitrate is always soluble. Anything nitrate or alkali metals is soluble, but silver bromide would be insoluble. Remember, the halogens with silver, lead, and mercury are insoluble. And so in this case, two of the ions are removed from the solution. The silver and bromine are removed from the solution. Potassium and nitrate are still found in the liquid, in the solution. So these are different now because we're going to be showing the states, and two of the ions will be removed from solution, in this case forming a precipitate. So in example 1, a precipitate will form, that insoluble combination will take two of the ions out of solution as the solid forms. So we have silver nitrate and potassium carbonate. So first we'll do our products. Silver plus 1 will form a compound with carbonate minus 2. And so you'll have silver carbonate plus potassium plus 1, nitrate minus 1. And so you'll have potassium nitrate. So now we have to decide about the states because they tell you in the description that solutions of silver nitrate and potassium carbonate are mixed. We know that the reactants are already dissolved in water. We know that nitrate is always soluble, so this will be AQ for aqueous. We know that potassium ions are always soluble, so AQ for the potassium carbonate. Had they said silver nitrate solid is added, you would write AgNO3 with the parentheses S for solid. Now we have to decide which one of these two products is going to be our precipitate. Potassium and nitrate are both always soluble, so those ions will remain aqueous, which remember means pulled apart, moving around free in the solution. Silver and carbonate are insoluble according to the solubility rules, so that will be your solid. And so the silver and carbonate ions are removed from the solution because they get locked into a solid. And then you would need to go back, of course, and balance your reaction. Another way to remove two ions from a solution in a double replacement reaction is to have the formation of a gas on the product side. In this example, potassium carbonate solution is mixed with a solution of nitric acid, and so on the product side we would form potassium nitrate, and the hydrogen from the acid would form carbonic acid with the carbonate. And so we have these two compounds. Now if you remember from some of the past sets, carbonic acid, H2CO3, is an unstable compound, and it very quickly breaks apart, decomposes into water and CO2. And there's the gas that forms. So the H and the CO3 ions are taken out of solution because you form the covalent compounds, Lewis structures of water and CO2. And then we need to add our states because the potassium carbonate was a solution originally, and potassium is always soluble, it's aqueous. Same thing with nitric acid, that was one of our soluble acids. On the product side, the potassium and nitrate will still be aqueous because potassium and nitrate are both always soluble. CO2 is a gas, and water is one of the few pure liquids that we have. And then as a last step, of course, go back and balance the reaction. So if you have one of the reactions that the two ions are removed from solution by the formation of a gas, usually one of these three compounds will form as your product. Carbonic acid, which decomposes very quickly as a product into water and CO2, and so there's your gas. Or you could have sulfurous acid, which decomposes following the same pattern into water and this time SO2, and there's the gas that would form. Or you could have ammonium hydroxide, which forms ammonia gas and water. And so in each of these cases, each of these reactions, you would see bubbles, you would see a gas being produced. In the third type of double replacement that removes ions from solution, you might have this example of solutions of hydrochloric acid and sodium hydroxide are mixed. So on the other side, you would have H and OH forming water, and then you would have sodium and chlorine forming sodium chloride. And so for the states, HCl, hydrochloric acid, is one of those soluble acids, so it would be aqueous. Anything sodium is aqueous, and the sodium chloride on the other side as well. Water we're going to show is a pure liquid, even though it's in a solution with these other ions, but water is a covalent compound, does not break into its ions, it's not able to be dissolved or soluble because it's a covalent compound, not ionic. And so in this case, the H and the O ions H and the OH ions are removed from solution. So on each of the examples on set 7, then write the double replacement reaction and then go back and assign states to everything. And so something on each of the product sides should form either a liquid, a covalent compound, a gas, or a precipitate, an insoluble combination of ions.